I'm excited to unlock the full potential of LLMs with UbiAI's platform. And so I wanted to just introduce myself real quickly and then introduce Dr. Amamou. And so I am at learnbold.com. I am a business owner as well, and I help industries and companies and organizations transform their operations with AI applications and generative AI as specifically. And I'd like to do so with the lens of responsible AI innovation, because obviously we want to drive innovation, but we want to do so at the same time while thinking of all of the unique aspects of AI and what you need to de-risk. So that encompasses AI governance, obviously data security, data privacy, all of the fairness and bias issues that you have to take into consideration for AI. So I live in the Washington, D.C. area, and I love collaborating and partnering with like-minded, innovative companies and individuals. And so UbiAI was one of those companies. And so I am so excited to introduce Dr. Walid Amamou. I'm sure a lot of you know him already. He is, again, the founder and CEO of UbiAI, based out of Raleigh, North Carolina. And UbiAI is a leading platform for training AI models, and specifically can also fine-tune LLMs. He's got a pretty storied background with a PhD in physics. He's ex-Intel. He's research engineer from there, working in 5nm node. And he serves Fortune 500 companies across finance, healthcare, and supply chain. So anything you wanted to add to your intro or professional credentials?
That's pretty much it. So yeah, we started the company back in 2021, UbiAI. Yeah, so basically our main mission of the company is really to help companies leverage AI the right way, not just by using generic AI that works only on prototypes but doesn't really work in production. So we help them to basically train the AI on their own business documents. We focus primarily on documents. So yeah, the goal is basically to bridge the gap between prototype to production. And as we're going to see in this presentation, the only way to do it is really to work on the data itself, to create really high quality data that will work for your business. So we've been very fortunate to work with Fortune 500 companies, thousands of employees, to smaller startups. So yeah, the field is very interesting, and right now with LLM is kind of shifting a little bit. And we're going to discuss as well how that works.
Yeah. Thank you so much for that context. And I will just introduce our agenda, and then I'll obviously hand it over to you. So what we're going to do is first talk about the fact that a bigger LLM like the GPTs of the world are not always better. So we're going to talk about, when it makes sense to use that versus other solutions, such as smaller LLMs that are fine-tuned on your own data. And then that is where we will move into more specifics about when it makes sense to fine-tune. And we'll specifically dive into parameter efficient fine-tuning LoRA, which I love. That's a new technology that I'm really excited to learn about. And then finally, we'll go into the actual UbiAI AI platform and how to fine tune with a demo. And then we'll obviously open it up for questions. But if you have questions during the session, please feel free to either just call them out or put them in the chat. And I will make sure that we can answer them during the session. So if something comes up as we're talking, please don't hesitate to let us know your question. All right. Off to you, Dr. Walid.
Great. Thank you, Sarah, for the introduction. Yeah, so basically, the first question we always have, right? Why can I just use ChatGPT for everything? That's pretty much like what everybody thinks. Like, someone not in the kind of production, phase, they will say, "Yeah, by the way, I can just use ChatGPT and it's all good." That's not the case. So ChatGPT is huge. So it's 1.7 trillion parameters. It's very capable for generic tasks. However, it comes with a lot of drawbacks. So the first drawback that I see in production with many companies is the accuracy requirement. So it might work on regular tasks like content generation or like blog generation, but when it comes to deterministic tasks where you really want the accuracy to be in the 95% and higher for your specific task, it actually doesn't perform well, and it's very unpredictable. Plus, you're actually paying a lot for per request. So imagine if you are processing millions of requests a day or like a week or a month, that's going to be super expensive. So I know that they're already reducing the price, but still, like I think at the production phase is going to be very expensive for you. Second is if you use these big LLMs, you're actually going to have issues with inference speed. So if your application requires quick response time, you might have issues as well using the bigger LLMs. And finally, hallucination. This is a big one as well. When it's not trained, it might look like it's giving plausible answers, but actually sometimes it will hallucinate. And there are many cases where people just use them in a chatbot, and they end up in court cases because they got sued for false information. And finally, privacy. So OpenAI, right, it's a closed source, so everything resides in their servers. They are probably targeted a lot in terms of hacking. So privacy could be an issue. Not just hacking, but also prompt injection. So people are, hackers are trying really hard to extract, PIIs and personal information from these big LLMs, commercial LLMs. And OpenAI is the big target.
Yeah, for sure. Can you give a specific use case where you have seen a lot of success in, what we're talking about, which is fine-tuning models,
right,
at with the lower cost and with
right,
the specific data that an organization has?
Yeah, so we're going to get to that actually in the next slide.
Okay. Yeah.
Sure. So what can we do? Yeah, the question is like, what can we do after this, right? So there is actually the new trend right now in terms of fine-tuning open source LLMs, like Llama, for example, or Mistral, and Microsoft also has some open source. So these are much smaller LLMs that instead of 175 billion parameters, are 1.7 trillion parameters. They're like 8 billion parameters, for example. And the key here is really fine-tuning these smaller LLMs. So, the vanilla LLMs, they will definitely underperform compared to the bigger LLMs like GPT-4. But when you fine-tune them, you actually can recover that performance, and they can even exceed the performance of the bigger models. So there was this study that was done recently, and they basically show on most tasks, like let's say like summarization, content generation, information extraction, most of the fine-tuned LLM do outperform the bigger, OpenAI LLMs, GPT-4 in this case. However, only one task they were not able to outperform it, even with fine-tuning. It was for code generation. So code generation, OpenAI was still the best. That being said, for all the other tasks, fine-tuning actually can really unlock the performance for these smaller LLMs. So the question then becomes, when does it really make sense to fine-tune, right? Should we go run and fine-tune every single time? Or is there some cases where fine-tuning is very important? So that really depends on two things from my perspective. It depends on the accuracy requirements, so like your application, what is the accuracy requirement for your application? And also, does your application require an external knowledge to be able to answer to successfully the request? So if, for example, your application is a simple, text generation, content generation, for example, and it doesn't really require deterministic high accuracy, you probably are okay with generic LLMs, and you can do some prompt engineering with like many shots and few shots to be able to kind of guide it a little bit. But it's still not going to give you high accuracy. Now, on the other hand, if you need up-to-date information about your business, knowledge, in that case, you probably need to use what we call retrieval augmented generation, which is RAG. So this will give you better accuracy in terms of reducing hallucination, but it's not going to give you better accuracy in terms of giving you kind of the reasoning, like giving you like the correct reasoning about it, or like a deterministic answer. So it's still going to be in the low accuracy regime, even though it's using your external knowledge. Now, so when do you really need to fine tune? So if you go to the high accuracy regime, for example, let's say we are doing information extraction, we want to extract, the social security number very accurately, or we want to extract, like certain numerical value, or, even like an address or anything like that. So in that case, you need very deterministic. You don't want like unpredictability, where sometime it will generate something and some other time generate something else. So in that case, you need to fine tune it on that specific task. Now, let's say you want a deterministic answer, but also you want to use your own knowledge, your business knowledge, instead of generic knowledge that was trained on. In that case, you probably need to do fine tuning of the LLM plus RAG. So here we can think of like customer support. So for example, like your customer will ask a question, and then you need to retrieve the data. Let's say it's your CRM. You need to retrieve the data for that specific customer. Plus, you need to respond in a very specific way that actually reflect your business style. In that case, you need to fine tune the LLM to respond like your business. Plus, you need to do RAG to retrieve the information. So this is like where you really need the AI to follow your own style. So I think these are kind of the main domains where fine-tuning is important.
Mm-hmm. So you're saying that for a customer service, even say chatbot, that's not necessarily manned by a human agent, in order to have the branding voice of the company along with the most up-to-date information in terms of new products or new deals, et cetera, then obviously the upper right-hand corner is where you want to focus.
Right, exactly.
Okay.
Yeah, exactly.
Perfect.
So I think like in 2025, we're going to really transition from this to this as people realize like how important like accuracy becomes in production. So I think ultimately fine-tuning will be kind of needed for most cases.
Mm-hmm. Yeah.
Okay,
I definitely saw that, by the way, at Verizon, because I was focusing on customer success, customer service. And so one of the issues was of obviously, where RAG can help with getting, up-to-date real-time information, but at the same time, using the fine-tuning to have that automated ability to really speak as if you are that spokesperson for that particular organization.
Exactly. Yeah. And sometimes it's not just even the style of the response, even like the reasoning. So there's like right now there's a trend, right? AI agent everywhere.
Yeah.
And this AI agent, they need to reason, right? That's one of the limitation. And in most cases, you need to kind of fine tune them to follow like a specific reasoning steps that actually will give you the best, probability of success. And that's where fine tuning also is important.
Okay, that's good to know.
Yeah. So what is the strategy, right? Like that you should take when you are approaching a project? So again, as I showed it earlier, it really depends on the accuracy requirement for your app. So you can, my approach, what I recommend for people like starting, from scratch, is start with off-the-shelf LLMs. So don't worry about fine-tuning, just start with GPT-4o Mini, or for example, or like Llama, the latest Llama, and measure the performance. And if the performance meets the requirement, perfect. You don't have to worry about it. You got lucky, and it's good to go. The next step is prompt engineering. So let's say like off the shelf is not good enough. You need to actually show a few examples, like many shots, chain of thoughts, and stuff, and then try it and see if it actually fulfills your accuracy requirement. The third step is fine-tuning. Fine-tuning is actually not that difficult, and I'm going to show why later on. You usually need like 100 to 5,000 examples on that specific task. So let's say you are trying to train it on email generation or information extraction. You just need like 100 to 5,000 examples to basically be able to fine-tune it on that specific task. Now, if you want to go crazier, you can do continuous pre-training. This is, I think, kind of out of reach for most startups. So this, you take the base model and you continue training it, basically doing that. And then really the hardest one is the pre-training from scratch. So basically, this is you create your own LLM from scratch, like OpenAI is doing. So that requires trillions of tokens of training data, and that's again out of reach for most companies. So I recommend, in terms if you have to fine-tune, definitely use this the fine-tuning approach that we're going to discuss, since you don't really need so many examples. Are there any questions? I heard a message, I think, Sarah.
Yeah, I just put a message for everyone to put any questions in the chat.
Right.
I don't think there are any right now, but anybody have a question?
Yeah.
Feel free to jump in.
Right. Mm-hmm. So in this talk, we're going to talk about fine-tuning, right? So we're going to focus on the third one, prompt engineering and many shots, chain of thoughts. There are a lot of resources out there. So we're going to just focus on fine-tuning. So traditionally, fine-tuning has been pretty challenging. So the way it works is you have to fine-tune all the parameters. So let's say you have 175 billion parameter model. You need to change the weight of every single parameter. So that's what we call full fine-tuning. So you change all the dimensions of the of the model. Let's say I have 12,000 by 12,000 matrix, for example, and you have to change all the parameters. So that's like extremely expensive and resource intensive. And this is like OpenAI will do that if they have to do full fine-tuning. The good news is in 2021, there is a new technique. It's called LoRA fine-tuning, and I'll explain how it works. It actually made it so simple for us, citizen developers, I would say, not GPU poor, to be able to kind of fine-tune our own models. I'm going to explain how LoRA works, but this is a really amazing technique that made it possible for even smaller startups to create really, competitive kind of models out there. So this is I'm not going to go into details about how LoRA works. I'm going to just give you a high level how it is. So the idea is you start with you take a snapshot of your pre-trained model. So this could be your Llama 3.1, for example. It has, let's say, like 8 billion parameter. So you take a snapshot, you freeze that model, you don't touch it. So you put it in a black box, you don't touch that model. And then you add two smaller matrices. So these are, you can think of as like micro models, very, very small matrices. So you have the matrix A and matrix B, and then you multiply these two matrices together. So these are new matrices, not related to the first one. And then what you do is you only fine-tune the A and B. You don't touch the W here, you just fine-tune the A and B. So you keep doing that. So you have the X as the input to your model, and then you change the parameters of A and B, and you look at the output, and you keep doing that over and over again. And during the training, you are actually changing A and B, but you are keeping W. So you are also gaining the knowledge of W, which is the frozen model, but you're fine-tuning just the A and B on that specific task. And then you keep doing that, multiple iterations, until you get a desired accuracy. And then what you do, we call these adapters, by the way. And then after that, what you do is you kind of merge the A and B matrices to the frozen matrix. So you have the merged weight together, and now you have a fine-tuned model. And the amazing thing is what you get here, the merged weights will be the same performance as the full fine-tuning.
Wow.
And this is 10,000 times reduction of parameters to fine-tune. You can fine-tune this in your computer, basically, which is pretty amazing. So I'm really excited about LoRA. I mean, LoRA has been around for a while. It's kind of everybody's using it, but this is a great technique that made it possible for us to fine-tune.
And so this is what you're using in the UbiAI AI platform when you do this step. Okay.
Exactly. Okay. So that's what we use to fine-tune these models.
Okay.
And this is the paper here. If you would like to check it out, it's an amazing paper from Microsoft. So yeah, basically this is how fine-tuning works. So that being said,
questions, by the way.
Yeah.
Yeah. So Tanmay is asking, how often should we fine-tune the model?
How often? Yeah. So that really depends on the output of your model in production. So you need to have like some monitoring pipeline where each request is logged, and then you have to look at do some evaluation of that. So if you are doing, for example, deterministic information extraction, you might look at the precision, the recall, compared to the ground truth. But you need to monitor your output. And then I think it depends from one case to another. You need to see if there's any drift or if the data is degrading or the output is degrading over time.
Yeah, that was actually Paula's question, following up on the one you're answering. What is drift like for these fine-tuned SLMs, the smaller ones?
That's a good question. So I really don't have the answer. It really depends on the case, to be honest. I don't think there was a study that does that. Maybe I'm not aware of, but I will check if there's a survey that surveyed, like tried different LLMs, smaller one, looked at the drift. But, even if there's a survey, right, I think you have to do it by yourself and check.
You have to continuous monitoring.
Continuous monitoring, yeah.
Okay. And then we have a question from
Sarah, can I interject?
Yeah.
Wasim, right? Am I getting your name?
Walid, yeah.
Walid.
Okay, Walid, sorry. I just wanted to ask you one more question. You mentioned that smaller models perform better on accuracy when fine-tuned in comparison to larger models such as ChatGPT and Claude and so on. Why is that the case? Because the higher the number of parameters, don't you think the fine-tuning will yield better result with larger models?
Right. No. So so basically, fine-tuning larger models will probably outperform fine-tuning smaller models. I'm comparing smaller models fine-tuning compared to vanilla models, like untrained fine-tuned models. Non-fine-tuned bigger models. So when you fine-tune a smaller, you get a better performance than untrained larger model. But if you have a larger model that you fine-tune, I think it's going to outperform the smaller models.
Okay. Yeah.
For sure. Yeah.
I got confused there. Yeah. Thank you.
Yeah.
But the economics are in your favor, right? If you are fine-tuning an open source smaller model, and maybe you could get.
The nice thing is, there is even open source bigger models, right? There's like Llama 405 billion parameters. So yeah, you can always fine-tune that.
I actually was talking with a company yesterday, and that was the issue, is just the expense is so, is kind of overwhelming. And so how to find that right balance between, accuracy and, something that's affordable, that company, we're talking about mid-sized companies can actually take on and not, feel like the output at the beginning is such a big barrier to entry there.
Exactly. Yeah.
So
No,
we
that's
got,
good. Yeah.
oh yeah, we got a question also from Karen. What's your suggestion to validate fine tuning and LLM models?
Yes, that's a great question. So that's what I'm going to show in the demo.
Okay.
So that's the evaluation part. Yes.
Yeah, and just to finish up her question, how do I know if the fine-tuned LLM model results are not biased?
Yeah, so that's a good question. I think at this point, I'm going to show. So after training the model, there are some metrics we're going to look at in this demo. So that also can give you an idea, a hint, about if it's biased or not. I'm going to show it. One of them is like confusion metrics, for example. But I think in most of the time, you need like human in the loop. You need someone to actually look at the data and see if it's biased or not. Yeah. So that's why I think like continuous monitoring is very important.
Sure. Okay.
So right. So even with LoRA, right, like as amazing as it is, you still need data. As I mentioned earlier, you need 100 to 5,000 examples. I know it's not a lot, but you still need data. And if you look at like in general, like what is the main bottleneck in terms of machine learning project becoming successful is actually data. So if you look at like data augmentation, data labeling, data cleaning, data aggregation, all of that, starting with data, that's almost like 80% of the work that's done. And training the model is only 5%, right? So the data cleaning, the data preparation is so important. So the lack of quality training data, I think this is really the main bottleneck in the space. And then if you look at fine-tuning platforms out there, AI platforms, most of them, they actually kind of skip this step, and they'll be like, yeah, by the way, just upload your files and we're gonna fine-tune it for you. But like, how do you get the files? How do you get the data in the first place? And that's where I think the system, kind of the workflow is broken. It's kind of fragmented. And that's where we come in. So in UbiAI, we actually streamline this entire process. So you can basically upload your documents. This could be a PDF, could be a scanned image you took it with your phone, could be like a Word file, and then you can upload it to our platform. So the next step is after that is you kind of curate the data and label it and clean it and review it. And then after that, you can fine-tune the model in our platform and finally deploy. So we support different LLMs and smaller models, not just LLMs. So we have Llama open source, where you can even fine-tune OpenAI, like GPT-4o or GPT-4o mini on your data that you just created. You can fine-tune a much smaller model because not everything revolves around LLMs, right? You might need to fine-tune a spacey model that's much, much smaller model, or like a BERT model. So we kind of integrate all these steps together to make it very kind of streamlined, so you can go from one step to another till you reach your goal. And again, this doesn't require any code. Everything's kind of streamlined, no code platform.
Mm-hmm. Yeah, from a business perspective, that data bottleneck is so, key to actually moving forward and getting your project forward to success. So I definitely appreciate that you offer both the data aspect as well as the fine tuning. Is so important.
Absolutely, yeah. I mean, we've seen it like over and over and over and over again. Like from our many companies we work with, they're stuck in that data part, right? Mm-hmm. And they come to us and be like, okay, this is our problem, and we kind of set the things up for them, and we streamline the entire process of data, curation, so they can actually move to the next step. Yeah. So the steps here is pretty simple. So you basically upload your files, upload your data. You can label it, you can review it. I call this like data curation step. After that, you can fine-tune your LLMs directly in our platform. So you don't have to know any coding, to be honest. You can do it with just a few clicks. And the next step is evaluating the LLM. This is another, I think, lack in the space, right? Like you fine-tune your LLM, but then you're like, okay, go figure out like if it's good or bad. So we kind of provide you with a lot of metrics where you can actually quantify the accuracy of your LLM, and kind of if there's any confusion between labels and so on. And the final step is deploying your LLM in production. So we provide you with a ready-to-use API endpoint that you can plug into your application. This could be your chatbot, could be a document processing platform. that will call that API and get back the data correctly. So the task we support in our platform is information extraction mainly from documents. So if you want to extract, entities or relationships, you can fine tune a model on that. We do also, we added LLM text completion. So if you want to do like content generation, summarization, text to SQL, like you want to fine tune it on text to SQL conversion, reasoning tasks. Let's say you have an agent and you would like to fine tune it on the reasoning steps. You can also do that. And finally, image classification. So in addition to document, we also do some image classification. So what are the most common use cases that we see for fine-tuning LLMs? We see actually AI agent for customer support is very common in businesses right now. And this is one of the kind of the most prevalent use case that we see. There's also compliance and risk analysis. So here, using an LLM to basically analyze, contracts or financial reports, and do some insurance like compliance documents, and extract information from them, and do some analysis, and gives you a report, for example.
Mm-hmm.
And another use case is content generation. So this is very domain specific. So let's say you're a healthcare practitioner, and you would like to generate a report about, a surgery, for example. It needs to go this procedure 1, procedure 2, procedure 3, and you want it to be in a very specific way. So that's where you actually fine tune the AI to do that. It doesn't have to be like medical only. Let's say you have you're replacing an engine, you're like a technical engineer, and you need to provide a report. You don't want to rely on ChatGPT to just give you something from Reddit that it learned. So you need something like fine tune it on your previously generated content.
Yeah, grounding your LLM on that particular domain. I mean, from a risk and compliance, GRC perspective,
Right.
it's just so key. I think, those of us who are really advocates for responsible AI and AI governance, a solution like this makes at least you feel like you're doing your utmost to ensure, the groundedness of your outputs and outcomes.
Yeah, I think it's not just groundedness. I think it's also consistency and predictability.
Yeah.
You don't want to get 2 different type of reports if you ask it twice in a row.
Right.
That'd be ridiculous, right? Like
Yeah.
if you do that in enterprise, that's like no go.
Yeah.
So you want something that's consistent,
Mhm.
predictable, and follow the same style every single time.
Yeah, that's amazing.
Yeah. So I think it's time for a demo. Unless there's some other questions we should cover.
Yeah, there's one question from Padmini, and it says, from a responsible AI perspective, how does energy consumption of fine-tuning play a role? So I guess the sustainability element.
Yeah, I mean, it's definitely, it's very advantageous. I think fine-tuning smaller LLMs is the way to go for in terms of energy consumption, because they require much less energy to run and to train. So the fine-tuning process itself, actually, it doesn't consume that much. But then once you run them in production, you're actually saving a lot of energy compared to like bigger LLMs.
Right.
You can even run them on your phone, basically.
Yeah, I think we're all looking for ways, not only from an economical perspective or financial perspective, but also from a sustainability perspective.
Right, yeah.
Yeah, make better, have more options in
Yeah.
how you deploy. Mhm.
Sure. So I'm gonna switch right now to the platform. I'm not sure if you see the screen still.
Yeah, we can.
Okay. All right, so this is the platform, UbiAI, for training AI models. And the use case that I'm going to show today is, I selected the use case a little bit like ambiguous. which is basically contract analysis. So what we're going to do is basically fine-tune. I'm going to show like the steps, fine-tuning an LLM on information extraction from contracts because they can be a little bit ambiguous. And then the second use case I'm going to show is for customer support. And I'm going to show how to fine-tune that as well. So, so contracts, right? So let's open a contract here. By the way, this is open, publicly available data, so it's not private. So this is a contract. This is a typical rental contract. So you have a bunch of text. This is just one of them, and a lot of information. And you need to make sense of that, kind of understand what's important, what's not important, what's noise, what's signal, what's noise. And so basically, you need to extract certain information from this. So in this case, what we're going to do is we're going to fine-tune an LLM to extract specific information that's very relevant to us. So for example, I have already a data set I uploaded here. So by the way, so to upload the data set is very simple. So you press on this upload documents, and then you, let's see, add the link here. So you press upload, and then you browse your files. And then you can add the PDF. You press open. You can add multiple PDFs. It doesn't have to be one. You can add hundreds at once. You press upload. And here you select the type of OCR engine. So in UbiAI, as I mentioned, we actually process all type of documents, even if it's scanned. So for this specific type, a PDF, we're using OCR to read the text. So you can press upload here. And then after that, what we're doing, once we're uploading right now, we are basically OCRing the text. So it's we can basically label it. So let's look at it, how it looks like now. So this is our contract, as you can see on the right side. And it's unlabeled right now. So to fine-tune the model, we need to teach it. We need to teach it what's important, what's not important. And these are the labels, the fields I'm interested in. So I would like to fine-tune the LLM to extract, these fields, because I really care about these fields. So I would like the list space, for example, any designated use, the name of the lessor, the signing date, the red flags. That's a little bit ambiguous, because the red flags in a contract, it depends on the expert, of the subject matter expert. So we need to teach it what's a red flag, what's not a red flag. So yeah, basically, once you define your fields, you can label. So let's say this is the name of the person. I can simply highlight here and label it. This is the lessor, I guess. Yeah, so I can label directly on the PDF like this.
I love the color coding.
Right.
That's helpful.
So let's do that. I'm not going to do this. I'm not going to bore you with this. I just want to show you how it works. So basically, you kind of tag it. So you can basically teach it what's important. But obviously, nobody likes to do this. This is what you call a value eroding step. Nobody likes to label. So we want to automate this process. So if you go to this prediction and go to configure prediction, you can actually select different type of task you want to auto-label. And then you can select here, for example, if you want to use an LLM to auto-label your data, or you want to use a custom model. So let's say I want to use an LLM. And then you can select like what type of LLM, like GPT or Gemini. We can even select a GPT-3, press save. And then here, what you can do is press on this predict button and let the LLM label for us. So this is kind of a way to auto-label the data in a much quicker, faster way. So now the data is back pre-labeled for us. So as you can see, this was done. This seems correct. This seems correct. This seems correct. You can go over this and kind of edit it. If there's anything missing, you can label directly here and assign a label to it. So You can do this also on a higher scale, like a bigger scale. So you don't have to predict per document. You can predict all the documents at once. So if you have hundreds of documents, you can automatically label them using your favorite AI model or using an LLM. So after the data is labeled.
We have a quick question on this.
Right.
To save money and time, can you weed out duplicates documents that are exactly the same but have different metadata, timestamp, last saved date, etc.?
Oh, you mean filter out the duplicate data?
I think Paula, you can come on board and let us know exactly. Yeah, she says yes.
Yeah, so we do that on not on a PDF, but like if you have a TXT file, we can like kind of do the comparison and remove the duplication. But we don't have it for PDFs as of today. Well, that's a good suggestion. We can definitely think about it.
Okay.
So, so after you prepare your data set, so you're happy with it. So let's say I have hopefully 100 examples ready here. Right now I don't have 100, but let's assume I have 100. You make sure you validate them. And after that, you go back to the models. And then here you can start training the model. So you can press a new model. And you can select different type of models. There's like a named anti-recognition model, which is information extraction pretty much. So for this specific case, for contract analysis, that's what I would use. So I would use named anti-recognition. And here we can give it a name, for example, contract extraction model. And then here you can select different type of models you can use. So as I mentioned, we support not only LLMs, but you can train smaller models like Spacey or BERT. Sometimes these are actually better, gives you better result than LLMs with enough data set, obviously. So you can select here your LLM of choice. So you can select LLM here, press next. You can assign a data set that you just created. So let's say we have data list abstraction. You can press finish. So right now we initialize the model, but we haven't trained it yet. So to train it, you have to go to this training configuration. And then here you can select the type of LLM you want to fine tune. So if you open this, you see that you have Llama 3, Mistral, the Solar, the GPT-4o Mini, and GPT-4o that you can fine tune directly without any code required. So after the fine tuning is done, what you will get is something like this. Okay, so this is, I fine-tuned GPT in this case on contract extraction. And what you see here are the scores. So this is obviously not a good score. So this is 0.3, like 30% F1 score, which is pretty low. The data was not enough. I think it was like 100 documents, but you probably need more data. But the point here is you have this dashboard where it basically tells you how is your model performance, like how did your model perform after training. So you get the F1 score here, you get the precision. I believe this is like true positive, based on the true positives and false negatives. And then you have recall as well. And in addition to that, you can even see the score for each label or field that you have defined. So for example, for this term of payment, I have 0.5, 56% accurate precision. And you can see all the labels evaluation here and performance. If you want to dig deeper, you can actually look at the confusion metrics, which is super handy. So this is basically what it tells you is you have the predicted labels on the x-axis and the true label. This is the ground truth on the y-axis. And then what you're looking for is kind of a clean diagonal terms. So anything that's non-diagonal, that's usually a red flag. So for example, let's look at this one, like the lesser name. So 23 instances have been predicted as lesser, and they were actually also lesser, but 2 of them were incorrectly predicted as lesser, but they're supposed to be less C. So there's like a difference here that tells you if your model is having a hard time distinguishing between different labels. And it gives you a recommendation here what you should do to fix it and so on. So the next step is obviously go back to the data set, add more data set here, and kind of refine tune it and keep measuring the performance as you go. So this is a great way to really evaluate the model performance of your LLM. So right now we talked about information extraction, but as I mentioned, UbiAI also supports text completion. So let's say content generation. So I have a use case here for customer support, which could be useful here. So let's open this quickly. So this is the different interface right now. This is for fine-tuning an LLM on text completion tasks. In this case, I want to fine-tune it to basically respond to the query of my client. So the data set is basically had a system prompt. So you tell it like you kind of condition the AI. You tell like your helpful customer support assistant. And the second is the user prompt. This is what your client will ask, for example. So let's say I want to help trying to edit my shipping address. And this is what's the expected response from the LLM. So in this case, we don't want the LLM to just respond. We also want the LLM to understand the intent, like what is the goal of this discussion. And here we also give it like a key here, intent, and this is what we expect, change shipping address. And then the category of the request, this is shipping. And this is super important also because this structure can be used later on to connect to another API that will basically extract the information that we need. So basically, you can upload data set here and review it and generate. So let's say you don't like this response, you can always edit it, change the temperature, for example. Let's say you can select different model here. I want to use GPT-4o mini, and I'm going to save my changes. And here I would like to generate a new response. Again, I can press generate, and then get a new generation and review it. Right, so this is the new generation from the LLM. Again, this is not fine-tuned, it's just GPT-4o mini. So you can basically edit here if there's anything, you can edit here and change it. So after you prepare your data set, you go to, again, the same workflow. So you go to your model, and then you select the data set that you just created. As you can see here, I have 3,000, I think, 3,000 entries. And then you fine-tune your model. So here, so basically, there's a difference between the information extraction metrics and the text completion metrics. So here, instead of using F1 score, precision recall, we are using different metrics. So for example, there's the blue score, the rouge score, rouge 1, rouge 2, and rouge L. So these actually measure the kind of the overlap between the reference, the ground truth text, and the generated text. So you can do it, rouge 1, I think it's 1 gram. So it measures the overlap between each single word. And then you have bigram, and then this is like multiple words. So you can measure the overlap. So here we have 48% overlap between the reference text, the ground truth, and the actual generated text. So you can actually iterate on this and try to improve this number even better. So
does that number depend on your use case, or is there a bar that you would recommend?
Yeah, so I think this number should be as high as possible. Definitely in the 90% would be good.
Okay.
Yeah. But again, so I don't think it's like this is a great, it's not like a complete metric that really reflects the performance of the model. It gives an idea about like, is this like kind of overlapping truth or not? I think you might also want to do like semantic similarity in addition to this to get like an overview of how semantically are similar between the ground truth and the response. But anyway, so you can always test this. So if you go to the playground, you can start typing again. So you are, helpful assistant. And then you start prompting. It's like, I would like to cancel my order. And just generate a response. And look at, okay, how is the fine-tuned models behaving? So as you can see, I didn't put any prompts here. I didn't ask it to do send back the data in like formatted JSON. It did it by itself. It knew exactly what it needs to do. So it added the category, order, intent, cancel order, response. And I didn't have to do any prompt engineering here. So yeah, basically, that's how it works. So after that, once you're happy with the results, you can basically click on this code here, and then you can copy paste this API code into your application and send the data and get back the response from this model.
Nice.
Yeah, there's another cool thing I was playing with, which is for patent claim generation. This is a really hard task, by the way. If you're like a patent lawyer, it's kind of hard to create claims. So here we trained an AI model that will generate claims for us, as if I'm a patent lawyer. So we gave it like 999 examples, and then we ask it to generate claims, given the description of the invention. This is the description. Please generate claims. And actually did a good job. So we trained it on this, and this smaller model was actually giving better results than the bigger models on this claim generation. Anyway, so here, just one example, going back to the contract. No, I don't think I have it here. Okay, never mind. I don't have the example, but anyway, so you can basically generate different data set for content completion, reasoning tasks, information extraction, all in a single platform.
So
5 minutes left.
amazing. Yeah. I can't wait to do some more testing on the platform. Does anybody have any questions at this almost top of the hour? This has been so insightful. Thank you.
Thank you.
Yeah.
Yeah, happy to answer any questions if you guys have any questions. Meanwhile, here, I just want to show you that we also support different data sets, so it doesn't have to be a contract only. Let's say you have an invoice, you can actually go here and not this one. Let's go to this one.
There's a couple of questions about trying it out, and I know there's a free a tier, so
Right.
yeah. And then also if you'll be sharing the slides.
Yes. I'll share the slide. I'm going to share the recording as well.
Okay. Awesome.
Just here, another example here, unrelated. So it's not contract, but invoice. You can also do the same thing, label it. But again, yeah, please try it out. It's very simple to use. You can fine tune one single model right now for free. You can upload up to hundreds of data sets. So if you need more documents you want to upload, please let me know, and we can increase the the limits. But yeah, so another example here I want to show is super important because someone was asking about like cybersecurity, security reasons. You can also train not an LLM, but like a smaller model on identifying PIIs. So here, just want to show you an example of what I mean. PIIs, right? So let's say you have an application, but you don't want to send sensitive data to the LLM. So you want to add like almost like a firewall where it just filters the data first. Right. So you can actually train a smaller NER like Spacey model to kind of identify all the PIIs. Like for example, I want to identify the first name. I want to identify the nearby GPS coordinates. Let's say the social security number. In this case, this is, by the way, public data set, public Bitcoin address. You want to make sure all sensitive data gets kind of hashed and anonymized before you send to the LLM. So this is another great use case where you don't have to use LLM, but you can use Spacey, much smaller model like Spacey model. Okay, so is that considered masking, or is that a different process? It's masked, yeah. So basically, you train the smaller model. The smaller model identify the PIIs, and then you mask it, you hash it. Okay. That's very important, yeah. Great thing is you can also download the model. So you don't have to be stuck with us. You can download the model here and go put it in your application, completely standalone and on your own server. The same applies for LLMs. So let's say you want to fine-tune LLM, but you don't want, for some reason, you don't want to keep it on our server because of privacy or whatever. you can always go and download the model, the weights, basically.
Mhm.
I
Well,
think
this is amazing, Walid. I think lots of people are really eager to try it out and
absolutely.
yeah, find out how it works. So I don't know if you want to put maybe some contact information for UbiAI
Right.
in the chat for everyone. I put my
Absolutely.
LinkedIn earlier, so I'm happy to
Yeah.
connect with anybody. I'll put it in again.
Then if you have any questions, please send us an email. I'm very happy to reply.